Hello, everybody. This is Mr. Malik speaking. Today, I'm going to go through a tutorial covering balancing chemical equations and just bringing you up to speed with how to balance equations. Some of you would not have looked at this since studying the topic C2, and in C5, the topic C5, this comes up quite extensively. You need to be able to balance equations in order to cover the other types of quantitative chemistry calculations that you will come across. So the first session I'm going to run today is going to be half an hour long, and we're going to cover balancing equations from start to finish. And in future, subsequent streams will cover moles, quantitative chemistry, reacting masses, and the whole works. You're welcome to grab a pen and paper and follow along. And later on, there'll be some questions for you to try out, and I'll give you a chance to cover those. So, without further ado, the first thing is balancing equations. Why do we balance equations? Well, it's to satisfy something known as the conservation, the law of conservation of mass. And this states that matter cannot be destroyed or created, only transferred. And we need to show this whenever we have about an equation, a chemical equation of any kind. So on the right hand side, for example, we have lithium reacting with bromine, give us a new compound, lithium bromide. And I started with a simple one because it's quite easy for you to tell and to have a look and see that actually this is unbalanced. Somewhere we have lost a bromine. One of the bromines from here have disappeared because there's only one bromine left. By the end of today, I want you to have a system by which you can use to calculate or balance any equation. And there are quite a few different techniques you can use that are out there on YouTube, online, that teachers have taught you. The one I'm going to use today gets you to analyze the equation at every point. So the first rule is you must not change any subscript numbers. And what I mean by subscript numbers are the small numbers you often find in equations which are down slightly lower than normal. And the reason is by changing that number, so for example, if I change Br2 to Br3, I'm actually changing the entire molecule, the compound. It's no longer the same chemical. So that's something we're not allowed to do at all. The only thing you're allowed to change is something called the coefficient. And that's a fancy way of saying the large number that usually goes in front of an equation. So for example, if I threw a 2 over here or a 3 over here, these are referred to as coefficients. And they're quite important. We'll come back to them much later on. Uh, the final thing is that the number of atoms in the reactants must always equal the total number of atoms in the products. And this ends up balancing the entire equation. So I'm going to go straight into this. Lithium bromine. Your first job in any kind of question is to analyze the question, work out what's going on. And the way I do this is to look and see which elements are present. The first element present is lithium, and the second is bromine. Now I'm going to go ahead and write that in the middle. The next thing is to count how many of each element you have on the left. So if we have a look, there's only currently one lithium on the left. So I'm going to go ahead and put a 1 underneath. And for bromine, Br2, quite evident, there are 2 bromines. At this stage, we're not actually answering the question, we're just analyzing. Similar thing over here, LiBr, we have one lithium, and we have 1 bromine. Now, at this stage, you are welcome to start changing the coefficients. So we can change the numbers in front um, to suit. By the way, a quick note. There is no number present or written down in front, but bear in mind that usually indicates that there's a number 1. Now, looking at this first equation, the easiest thing for us to do is to try and balance the bromines. We've got 2 over here, we've got 1 over here. So what we need to do is multiply by 2. And I'm going to go ahead and put a big 2 in front, 2 LIBR. Now, it's important every time you make a change to the equation, you re-evaluate the numbers underneath. This now means I have 2 lithiums, so I'm going to go ahead and change that numbering underneath. And I also have 2 bromine atoms. So far so good. And just a quick check, we've now balanced the bromine. The lithium is still unbalanced. But if you look closely, there are 2 lithiums on the right. There is only 1 lithium on the left. An easy way to fix that is to chuck a big number 2 in front of the lithium. And again, you need to re-evaluate. At this point, you'll notice that there are 2 lithiums on the left, 2 lithiums on the right. So this is a fully balanced equation. And I'm going to go ahead and pull all of this away just so we can see the final answer. Example number 1. Have a go. I will give you about a minute and a half to 2 minutes to have a go at this question here. Make sure you show all your working out underneath, following the steps outlined above. Here we go. Okay, this is quite a nice straightforward equation. And if we go through again, the first element is hydrogen, and the second element is oxygen. So we're going to go ahead, chuck those underneath, H and O. If we count on the left, we have 2 hydrogens and 2 oxygens. And on the right hand side, we have 2 hydrogens. And this time we have 1 oxygen in the water and 2 oxygens as a gaseous molecule. So altogether there are 3 oxygens. Now, to balance this equation, there's several ways we can go about doing this. We don't actually, when we're balancing, odd numbers are quite difficult, quite tricky to balance. And if we look at O2, that's a nice even number too. The problem is with the oxygen over here on the left. There's only 1 there, it's an odd number, and that's what's throwing the total completely out. So what we're going to go ahead and do is we're going to try and get rid of the odd number of oxygens over here. And we're going to go ahead and chuck a 2 in front. Because now, if we recalculate, we have 2 oxygens in the water, 2 oxygens in O2, which gives us a nice even number 4. Don't forget, we've also changed the number of hydrogens, which means 2 times 2, which gives us 4. As a side note, you can think of the big number 2 in front, the big coefficient, as being a bracket in maths. And it means to multiply everything that comes after it by 2. Going back to the equation, so we're now re-evaluated. Quite easy, we chuck a 2 in front, and we get 4, 4. Just something to get us going, worth about 1 mark. Next question. Again, I'm going to work through this one, but it's quite straightforward. Example, it's a common example. NaCl. If we count on the left, there is 1 sodium. There are 2 chlorine atoms. On the right, a single sodium, a single chlorine, and we're ready to start balancing and adapting. I'm going to use a purple here. So straight away, we can make a change with chlorine. And the way we can do that is to chuck a big 2 in front, change the coefficient of NaCl. And remember, it's like a bracket, so we multiply everything after it by 2. That should give us 2 sodiums, 2 chlorines. Chlorines are balanced, the sodium still has issues. And we go ahead and put a 2 in front of Na on the left. Now we are purposefully starting from quite basic equations, and we are going to build up to more complicated examples. But it's important that we perfect this as we go along. At the end of this video, I'll post a link to extra questions that you can download and practice at home. Feel free to leave comments below as well on any questions that you struggle with or anything you'd like to see in future, and I'll do my best to action them. Have a go at number 3. Okay, the next one. So we have Mg, H, and Cl. Go ahead and chuck a 1 in front of the Mg, 1 in front of H, and a 1 in front of Cl. On the right hand side, we have 1 magnesium, 2 chlorines, and 2 hydrogens. So straight away, we have an issue. Now, the best way to do this is to have a look and see what needs to be changed. And quite straightforward here, HCl. There are 2 on the right, there's only 1 on the left. So I'm going to go ahead and chuck a 2 in front of HCl. That gives us 2 hydrogens, 2 Cls, and that's balanced for the moment. It's quite straightforward. Sorry about any, I know there's been a few issues with audio and the wrong link, but I hope it's much better now. If it isn't, just drop me a comment in the comment section. This next one, I'm going to give you about a minute to have a look and see if you can analyze. My hint to you, SO4 on the left, it doesn't change on the right hand side. It's still an SO4 group on the right hand side. So well, it's the same on the left and the right. You can actually group them together. And that means when you write it out underneath, you can use aluminium, hydrogen, and instead of doing S and O, we can just use SO4. Keep it grouped together. And if you count how many SO4s there are on the left and the right, you're in business. My final hint to you is to put an imaginary bracket around SO4 and count how many there are on the left and the right. Off you go. Okay, so let's go through this example above. This is a reaction of aluminium and sulfuric acid, and it makes aluminium sulfate and hydrogen gas. It's your typical acid-metal reaction. So if we count ahead, we've got 1 aluminium on the left, 2 hydrogens, and be very careful here. A common mistake is to assume that there are 4 sulfates. There's actually only 1 sulfate group. Now to explain that a little bit further, the best way I can describe it is the number 4 is only for the oxygen. So when we look at SO4, the sulfate group, there's only 1 sulfate group, really. On the right hand side, we have 2 aluminiums, and this time we have 3 sulfate groups. So straight away, something slightly different. And then for hydrogen, I'm going to make sure I put it in the right place. There are 2 hydrogens. So the first thing we can do probably the most obvious difference is the sulfate. There's a big issue here, 1 to 3. The way to fix that is to multiply this by 3 to get this side to 3. And the only way you're allowed to do that is to put a big 3 in front of H2SO4. Remember, it's like a big bracket. So we've got to multiply everything inside that bracket by 3. That gives you 6 hydrogens, 3 sulfates, or sulfate groups, and that's all done. And then the next thing we can do is have a look at aluminium. There are 2 aluminiums on the right, only 1 on the left. So I'm going to go ahead and chuck a 2 in front of aluminium. And then finally, hydrogens. There's an issue with hydrogen. 6 hydrogens on the left, only 2 on the right. So we're going to go ahead and chuck a number 3 in front of H2, which changes to 6. So those of you who got this correct, this is the kind of question that may come up in your GCSEs. It's designed to be slightly trickier, but you have the skills, you have the tools now to do this correctly. You got that correct, well done. And that moves us on to the next. We've got ethane and oxygen, combustion of ethane. If you have a go at this one here, 6. I mean, I'm going quite rapidly here, but we must list all of our elements, C, H, and O. If we count the number of carbons on the left, we have 2, 6 hydrogens, and 2 oxygens on the left. On the right hand side, we have 1 carbon, we have 2 hydrogens, and we have 3 oxygens altogether. Now, one of the immediate things we can do, and it's slightly different on this one here, is have a look and see that there are 6 hydrogens on the left, 2 on the right. So we're going to go ahead and chuck a number 3 in front of H2O. And what that should do is change our numbering. 6 hydrogens. The oxygens also change. We have 3 oxygens on the right, but we also have 2 in CO2, which gives us 5. It says a slight issue with the video, but it should be fine. I think we're still good to go. On the left hand side, we've got 2 carbons. We've only got 1 on the right hand side. So we're going to go ahead and chuck a 2 in front of CO2. And that will change both your carbons and your oxygens. So this time we now have 4 oxygens in CO2. And we have 3 oxygens over here, which give us 7 altogether. Stand back and admire. Your carbon is balanced, your hydrogen is balanced, but the oxygen is not balanced. And the key thing here is to go from 2 to 7. A bit garish. To go from 2 to 7, we've got to multiply by 3.5. So that means we have to multiply oxygen by 3.5. And that gives us 7 oxygens altogether. So to clarify, 3.5 times by 2 gives us 7, which is now balanced. So this is the balanced equation. But there is one last issue which we haven't seen until now. And the issue is we do not like, as chemists, decimals. We don't like to have non-whole numbers in our equation. So we need to find a way to get entire whole numbers into our equation. And the easiest way to do this is to times everything in the equation by 2. If we do that, we end up with 2C2H6 7 oxygens, 4 carbon dioxides, and 6 H2Os. And you could double check the math to make sure it adds up, and it does add up. Here's another question for you, and then we'll end with the final question down below, number 7. Question here, sodium. We have carbon, and we have oxygen, and finally hydrogen. Now some of you may be wondering, why can we not keep CO3 together? And the simple answer is, CO3 is not the same as CO2. They're two different molecules, two different compounds, and therefore we cannot group them together like we did before with sulfate, SO4. So we count them individually. If we count, we have 2 sodiums on the left, 1 carbon, total number of oxygens. Now, an important point here, NO3 we can group together, because NO3 on the left is still NO3 on the right hand side. So that's one I missed out from the list. NO3. Going back to counting, so 2 NAs, 1 carbon. Now the oxygens, we have to be very careful that when I count the oxygens, there are 3 over here. There are 3 in NO3, but I'm counting NO3 separately. I'm counting it as its own entity, as its own chemical. So I must not count it when I'm counting oxygen. There are only 3 oxygens in this molecule which do not belong to anything else. H, 1 hydrogen and 1 NO3 group. I'm again putting an invisible bracket around NO3. On the right hand side, 1 sodium, 1 NO3, again invisible bracket, group it together. There's only 1 carbon on the right, sorry. Altogether, we have 1 oxygen and 2 oxygens here, which makes 3. Hydrogen, there are 2. This sets up a situation where we need to balance. So the first obvious one we can do is sodium. Chuck a 2 in front of Na and calculate 2 NAs, 2 NO3s, and leave it there for the moment. Na is now balanced. The next obvious change is at the bottom. So I'm going to chuck a 2 in front of H, NO3, and that gives me 2 and 2. And if we look through, the equation is now balanced. Question 7. This is probably the last one for this video. Butane and oxygen, combustion of butane. Butane, elements carbon, hydrogen, and oxygen. 4 on the left, 10 on the left, and 2. On the right, 1, 2, and 3. The first change is to put a 4 in front of CO2. That gives us 4 carbons. The oxygens change. There are 8 oxygens in CO2. And then there is only 1 on the right hand side. So that gives us 9. The next change, 10 hydrogens on the left, only 2 on the right. So we multiply by 5, which gives us 10 hydrogens. And now we had 8 oxygens in CO2, plus 5 gives us a new number of 13. Carbon is balanced, hydrogen is balanced, oxygen is not balanced. Half of 13, because remember we're trying to go from 2 to 13. We have to multiply by 6.5. I'm going to make a bit of space for myself. and that gives us 13 oxygens. This is now balanced, it's looking good. But remember the issue, which is we do not like to leave decimals in our balanced equation. We need nice round whole numbers. Easiest way to fix that, multiply everything by 2. So we end up with 2C4H10, end up with 13, 8, and finally 10. And again, you can double check if you want by doing the math and see whether it's balanced out or not. That brings to an end this first tutorial on balanced equations. I will leave questions for you online. And for those of you watching back, not live, I'll leave the link in the comments and in the description for you to practice. And our future sessions will cover other material, so looking at reacting masses and moles. It's been real. Don't forget to like, subscribe, and share. We started from the bottom and now we're here. We're going up. And all the best with your studying. Take care.